Today in Math 20-1, we're going to look at topic 7.4, finish off chapter 7 on reciprocal functions, page 392. Reciprocals. Let's remember what reciprocals are. If we had a number like 4/3, the reciprocal of 4/3 is 3/4. If we had a whole number 7, which we can express as 7/1, the reciprocal would be 1/7. The same with x. If x is actually x/1, the reciprocal of x is 1/x. If we have xy, the reciprocal is 1/xy. -9 is -1/9, because we will move the negative to the top with a fraction always. And -3/2 is going to flip, get the reciprocal to over -3, and then we remove the negative to the top to get -2/3. The product of any number and its reciprocal is always 1. For example, if we looked at -3/2 times -2/3, you're going to get -6/6, which is 1. Reciprocal functions. If y is equal to f at x, the reciprocal is defined as 1/f at x. And if f at a is equal to b, then we say 1/f at a has got to be 1/b. And of course, a and b cannot equal 0. Let's look at an example and try to make some sense out of all that mumbo jumbo. Here in example 1, it says to sketch the graphs of y equals x and its inverse, y equals 1/x. Well, here we have the graph of y is equal to x. The inverse is going to look totally different. Y equals 1/x, we're going to plot some points, and it's going to look like this. Y equals 1/x. There's a vertical asymptote, as it's called, at the non-permissible value of 0, because in our graph, x cannot equal 0. There's also a horizontal asymptote at y is equal to 0, because 0 is not in the range of the function. Because I have 1 in the numerator, my denominator will never equal 0. So when we look at our original function, range is going to be y is any real number and x is any real number. For the domain in our inverse, 1/x, notice that it's going to be any real number except x cannot equal 0, and the range means that y cannot equal 0. And if we plotted our points for x and y, this is how we get the inverse of 1/y. Let's change that. Stop. Let's change that. Now we'll call it 1/x, and y equals 1/x. So in our first graph, when x is -2, y is -2, you'll notice that 1/x is going to be 1/2. When x is -1, y is -1, and 1/1 is still the same point. When x is 0, y was 0, but 1/0 gives us an undefined, an error message. That's why there's going to be an undefined value at 1/x. Example 2. Let's graph a function 2x plus 5 and its reciprocal. Well, if you plot some points for y equals 2x plus 5 and 1/2x plus 5, you're going to first of all notice that x cannot equal -5/2. That's our non-permissible value. That also tells us that's where there's going to be a vertical asymptote. From that point, we just have to plot a few points to see where our graph's going to go, and there's our graph of y equals 1/2x plus 5. Then if we draw on our original line, you can see how it passes through. That's the graph of y equals 2x plus 5. In example 3, we have y equals x squared minus 4. They want us to graph that and its reciprocal. If we plot some points, plug in some values to see what it's doing around the origin, X is negative 2, so negative 2 squared minus 4 is 0. Negative 1 squared minus 4 is negative 3. 0 minus 4 is negative 4, and so on. So there we have the points from our graph. When I take its reciprocal, I can just take 1 over all those points. I can also factor the denominator, and when I factor the denominator, now I can see that x cannot equal 2 or negative 2, so that tells me that there's going to be 2 vertical asymptotes. So I'm going to draw those in before I draw my curve. There's my original function. I draw in my asymptotes in those red dots because I don't have an ability to draw in dashed lines. And then when I plot some points, that's what my curve is going to look like. So the black curve is our original function, y equals x squared minus 4. Its reciprocal function is the red line, not including those red dots. In example 4, if you're given the graph of an inverse function, they want us to graph the original function. Well, here we have the graph of an inverse function. Because of its shape, I can already tell that it's going to be the inverse of a line. Now, what do we know? We know that there's a vertical asymptote at x equals 2. What does that tell us? Well, since this graph is undefined at x is equal to 2, the original graph must have the point on it of 2, 0. So now we have 1 point from our graph. We're given the point 3 and 1 over 3 on this graph. That means that the original graph must have had the point 3 and 3 over 1, or just 3, 3. Now we can't read any other points from the graph. They don't go through anywhere we can tell exactly. So that's okay, because 2 points are more than enough to be able to draw a line. So what we're going to do is we're going to plot the points 2, 0 and 3, 3, and then draw a line through those 2 points. Here we go. You can now have drawn your original function. So here's our first point. There's the second point. Put our line through it, and we're done.